So what happens when we, draw a line? It seems so basic.
Right. Just making a distinction.
Yeah, saying this is different from that. But apparently that very human act has some pretty surprising consequences.
Especially in places like mathematics and physics.
That's what we're digging into today. We've got this text that explores how our need to categorize things really shapes how we understand these big fields.
Exactly. We're talking about fundamental distinctions like 0 versus 1 in math.
Okay.
Or in physics, the difference between your measuring device and everything else around it.
And even just distinguishing objects in physics theories, right?
Right. And the text suggests these seemingly simple acts have some, well, let's say unexpected ripple effects.
Okay, let's start with math then. You mentioned 0 and 1. We all learned to count. Seems straightforward. How does separating 0 and 1 cause ripples?
Well, it's the very foundation of counting, obviously.
Mm-hmm.
Making that distinction lets us assign numbers. But the interesting point here is that this act, this separation, seems to introduce a kind of uncertainty right at the core of what we mean by number.
Uncertainty in math.
Yeah, or maybe a lack of complete control over the definitions. Things like number itself, infinity, even continuity, that idea of a perfectly smooth, unbroken line. It's like by drawing the line, the things you've separated become a little harder to define absolutely. The source even mentions that, the really important people often don't need to produce these strict definitions.
So focusing on the separation makes the fundamental concepts a bit fuzzy.
Kind of, yeah. Think about continuity and that smooth ramp idea.
Okay.
When we distinguish individual points or numbers on that ramp, suddenly we're seeing it maybe as tiny steps. It makes the original smooth idea less clear-cut.
Right, I see. So that basic distinction has deeper conceptual effects. Let's shift to physics, measurement.
Okay. So to measure anything, you absolutely need to distinguish the tool.
Your ruler, your thermometer.
Exactly.
Yep.
From the thing you're measuring.
Right.
That's measurement 101. So where's the clean line between the measuring apparatus and the thing being measured then? It's not always so sharp.
Okay, so the observer and observed aren't always neatly separable. That makes a certain kind of sense. What about building physics theories? Defining distinct objects, planets, atoms, whatever, to explain things.
Yeah, this is maybe where it gets most profound. Our theories rely heavily on identifying distinct objects. That's how we build models.
And then we compare the models to reality, to our measurements.
Correct. If reality itself doesn't actually operate based on these sharp human-made distinctions,
then our models will always be, what, approximations?
Essentially, yes. They'll hit a wall. The source notes that quantum mechanics seems to pop up right at the limits of our tools, our ability to clearly define and measure separate objects.
Which kind of suggests...
It suggests there might be a mismatch, right, between our neat conceptual boxes and how reality fundamentally operates.
So what's the alternative?
Well, the text lays out two broad possibilities. Either reality truly is made of distinct separate things, like our theories assume, or maybe reality is fundamentally a single, undifferentiated whole. If that's the case, then our constant human habit of drawing lines, of making distinctions.
It might actually be preventing us from seeing the bigger picture, obscuring a deeper unity.
That's the implication. We might be imposing distinctions on a reality that doesn't inherently have them, causing problems for our understanding, especially at the extremes.
Wow, okay. So, boiling it down, this fundamental act of making distinctions totally necessary for us to function and do science, it also comes with some serious, often hidden consequences.
Definitely. It affects definitions in math, complicates measurement in physics, and potentially limits the reach of our physical theories.
It shapes what we even think reality is.
Exactly. And the source really pushes us to consider what reality is actually made of, beyond just our convenient categories. It's about questioning the tools themselves, not just what the tools measure.
So for you listening, if you're trying to really get to the bottom of things, maybe the takeaway is pay attention to the lines, the ones you draw mentally every day.
Yeah, how does separating things affect how you understand them?
Could that very habit of differentiating, of slicing things up conceptually, actually be hiding a more connected, perhaps more fundamental reality? Something to think about.